see that again? It's hard to catch the first time.
It's commonly assumed the search for alien life came in more recent times, a modern concern born from fiction, science, and strange lights caught on grainy footage. But that's not the whole story. For well over 2 millennia, astronomers, philosophers, and bishops looked up and wondered what might be beyond. Some of them are now celebrated as the brightest minds in history, but not for what they said about life beyond Earth. This video isn't a story of brilliance or great scientific discoveries. This is a story of speculation, mistakes, and the endless reach of human imagination. This is the story of how a bishop launched a debate about aliens. In the late 13th century, Bishop of Paris Etienne Tempier issued 219 propositions to resolve religious questions. Among many statements clearing up speculations about God, his rules, and his intentions, one proposition stands out. In Proposition 27, he condemns, in the name of the Church, all who hold the position, quote, that the first cause cannot make more than one world. Or in other words, the Church just promoted the idea that there might be different worlds. To understand the severity of this statement, we need to zoom out and get a few things straight. First and foremost, the debate didn't start with aliens. The idea of inhabitants appeared around 1300, but before that, the debate was about worlds and if something like our world could appear twice. The dominant worldview at the time was based on the teachings of Greek philosopher Aristotle. Aristotle believed that the universe was made out of 4 elements: earth, air, fire, and water, each striving for its natural place in a single ordered cosmos. Each element has its proper place. Earth moves to the center, fire to the circumference, and water in between. If there were several worlds, the same element would have to be in different places at the same time, which is impossible. His system made the idea of other worlds simply impossible, because everything was built around the one world we can't perceive. By his definition, all the visible phenomena as seen from our Earth, including the Earth, Sun, Moon, planets, and fixed stars, were considered part of the one and only world accessible to human senses. But not everyone came to the same conclusions. About a century before, a group of Greeks posed the surprisingly modern question of whether the visible world is everything there is. The atomist view was popularized by Democritus and states that the whole universe consists of tiny, indestructible atoms without any purpose or cause. More importantly, the atomists believe there is an infinite supply of atoms, and therefore an infinite number of worlds. It seems absurd that in a large field only one stalk should grow, and that in an infinite space only one world exists. This idea was born out of the assumption that since there is an infinite supply of basic matter, everything you can think of can and will happen. When abundant matter is ready, when space is to hand, and no thing and no cause hinders, things must assuredly be done and completed. It might be easy in retrospect to notice that these two systems stand in stark contrast to each other. However, this might not be a coincidence. There are reasons to assume the atomist view of infinite worlds actually inspired Aristotle in the first place. There is no visible necessity inside Aristotle's physics or cosmology that he should address the issue of multiple worlds. In fact, the very opposite might be true. Other worlds were seen as an entity that could not be perceived by the senses, so it seems very much out of place to talk about different worlds in a system that seeks to explain the everyday world. It is apparent that Aristoteles knew of the atomists and actively opposed his system to them. It is perhaps one of the greatest ironies in the history of the debate about aliens that while the passionate atomist system fell for the most part on deaf ears, the rejection of multiple worlds inspired numerous thinkers and philosophers to discuss everything in great depth while not leaving the fangs of the Aristotelian one world view. In the end, the strong connection between atomism and the idea of multiple worlds wasn't able to be tested. Its fate was ultimately decided by the people who got to read it, which itself was a big problem. The preservation of atomist scripts was extremely poor. Most original works were not copied and, in addition to that, were seen as highly problematic for Christian and Islamic theory. The Aristotelian texts, however, survived exceptionally good. There are lost scripts, but it is believed that all branches of his knowledge are covered by preservation, which can't be said of the atomists. It isn't too far-fetched to assume that scribes simply had no incentive to preserve what was seen as evil at the time. With the church gaining more and more popularity, it is of no wonder the church accepted the Aristotelian system and tossed the atomist package into the abyss of doctrinal errors, where it stayed for 1,000 years. And this is precisely where we come back to Etienne Tempier's proposition 27. That the first cause cannot make more than one world. It was this big of a deal because it challenged the absolute authority of Aristotelian science and opened the door for new ways of thinking about the cosmos, provided by the most powerful institution of the time, the Church. It should be said that the aim of this proposition was not to assert a multiple world stance, but to condemn accounts that restrict the power of God. So the intention of world was, God could create multiple worlds even if we know that he happened to make only one. An implication that was not made clear enough and led room for interpretation. As soon as the ink had dried, the speculation about life on other planets began to flourish and started a new era of questioning the night sky. The most prominent voice of early speculation was a Christian bishop and philosopher called Nicholas of Cusa. In his book on learned ignorance, he writes, "Rather than think that so many stars and parts of the heavens are uninhabited, and that this earth of ours alone is peopled, we will suppose that in every region there are inhabitants." For the first time in history, someone put living beings on other planets. In earlier scripts, we can find how the Aristotelian system is still deeply embedded in his mind while he describes the sun. Nearer the center there is a sort of earth, at the circumference a sort of fiery brightness, and midway between them a kind of watery cloud and clearer air. The implications are as obvious as they can be. But still, Cusa refused to accept the idea of just one world, an important pioneer act as it turns out. It is a reasonable thought to suggest Cusa might have based his assumptions on the atomist view. However, it is well known that Cusa didn't have access to any atomist texts at the time. The single surviving copy of Lucretius' scripts, discovered in 1417, was in Florence while Cusa studied at Padua. Furthermore, he never cited any atomist views. It is an exciting time in the history of the debate. The invention of the telescope is still almost 200 years away, and the debate basically lost all its limits. Nicholas of Cusa did not wait too long to start with one of many unhinged claims we will see in this video. It may be conjectured that in the area of the Sun there exist solar beings, by nature more spiritual than those who may inhabit the Moon, who are possibly lunatics. With Nicholas of Cusa later being assigned cardinal by the Pope, you could come to the conclusion that the Church was rather open to the idea of multiple worlds. But it has to be pointed out that all of this was still in the scope of the geocentric universe, and still in full control of the Church. So it became a clear mission of the Church to align every new speculation in some way with the Bible. As to the question whether Christ by dying on this earth could redeem the inhabitants of another world, I answer that he is able to do this even if the worlds are infinite. But it would not be fitting for him to go into another world that he must die again. While the Church was busy dancing on razor's edge between multiple worlds and Christian doctrines, an important figure in the debate started to cook a revolution. Nicolaus Copernicus is central to the debate about extraterrestrials, not because he believed in them, the question didn't seem to interest him, but because he was the first person to propose, based on observation and calculation, that Earth was not the center of the visible universe. In the early 16th century, Copernicus began writing what would become his life's work, called On the Revolution of the Heavenly Spheres. It argued that the Earth rotates around its pole, that the Moon orbits Earth, and that Mercury, Venus, the Earth-Moon system, Mars, Jupiter, and Saturn all travel around the Sun at their own rates. Copernicus' heliocentric model accounted for important oddities that the old Aristotelian system couldn't possibly explain, like, for example, the occasional backward motion of planets against the background stars, which by today's standards couldn't possibly be explained without the Sun at the center. But despite being correct, the heliocentric system was far from being accepted, not least because it amounted to a huge demotion for Earth. It left Earth with only one cosmic companion, the Moon, and forced readers to reckon with the idea that we live on a planet that is just like any other, hovering in deep space with no purpose. Copernicus knew his theory would provoke the Church, which may be the reason why he declined to publish it during his lifetime. The book that would put the world to its rightful place was released in 1543, the year Copernicus died. For his scientific contemporaries, the ideas presented by him were tempting, but not really easier to use than the geocentric system, and it did not produce more accurate predictions of planetary positions. Copernicus was aware of this and could not present any observational proof. Galileo's telescope would need another century to be invented, so he had no choice than to rely on arguments about what would be a more complete and elegant system. Which in retrospect sounds like he had one hell of a gut feeling, but unfortunately didn't present him as more believable back then. The Copernican model appeared to be contrary to common sense and to contradict the Bible, which was more than enough for it to be disregarded. The astronomer Tycho Brahe kinda liked the mathematical benefits of the Copernican model, so he constructed a cosmology precisely equivalent to that of Copernicus, but with Earth held fixed at the center. While reading through scripts and texts, it becomes apparent that at the time the majority of thinkers tried to satisfy the two main sources of knowledge, Aristotle and the Church. Everything outside of that was seen as rebellious and was rigorously suppressed. It needed another generation before a community of practicing astronomers appeared who tested and accepted heliocentric cosmology as the only possible truth. While Copernicus took a rather passive approach, his follower Giordano Bruno was not so cautious. In 3 sets of dialogues published between 1584 and 1591, Bruno argued that at least some of the stars are suns with their own planets, and that some of these planets must have their own residents. Innumerable suns exist, innumerable Earths circle these suns, living beings inhabit these worlds. He was merciless in his statements and took no steps back to respect the view of the Church. The Earth is not the center of the universe, it is not motionless, it is not unique. Bruno's daring view obviously conflicted with long-standing doctrines of the Church, and they did not shy back from punishing those who stood against him. Bruno was arrested in 1592 on charges of blasphemy and heresy and sent to Rome, where his trial lasted 7 years. On February 17, 1600, he was burned at the stake. His execution was widely followed by people living outside Rome and ultimately had the intention of putting down over-ambitious astronomers. While the discussion until now really had no way of proving anything and was based on religion and thought, the whole debate would experience a gust of change with the introduction of Galileo Galilei's telescope. The telescope allowed Galileo to be the first to take a look on distinct details of celestial objects. In his book Sidereus Nuncius, Galileo announced the discovery of mountains on the Moon and 4 satellites orbiting Jupiter. Alongside detailed drawings of what he saw on the Moon, he states that the surface of the Moon is not unlike the face of the Earth, and that if anyone wished to revive the old opinion that the Moon is like another Earth, its brighter part might represent land and its darker region that of water. Johannes Kepler, a friend of Galileo and one of the greatest astronomers in history, received a copy of his discoveries, and he was, let's say, quite excited of what his comrade had found. Within a matter of weeks, he went on to make a series of assumptions. Kepler's first target was this distinct circular feature of the Moon in Galileo's drawings. Where Galileo had only expressed wonder, Kepler proposed that it might be created by intelligent beings who, quote, make their homes in numerous caves built out of that circular embankment. Is it a work of nature or of a trained hand? Furthermore, he seemed confused how the inhabitants would deal with the sun. I certainly do not understand how those inhabitants of the Moon can bear the sun's terrific heat at full moon. And with that, we only touch the surface as he goes even further and divides lunarians into species. Even without me saying anything, it is not difficult to infer how much the subvolvents differ from the prevolvents in all other respects. The subvolvents being Kepler's designation for the near-side lunar inhabitants and the prevolvents the far-side inhabitants. It's honestly fascinating to read how one of the greatest astronomers of history writes pages and pages about something that only took place in his mind. And it wasn't in the slightest limited to the Moon, as he goes on and comments on the discovery of the 4 Jupiter moons. The conclusion is quite clear. Our Moon exists for us on the Earth, not the other globes. Those 4 little moons exist for Jupiter, not for us. Each planet in turn, together with its occupants, is served by its own satellites. From this line of reasoning, we deduce with the highest degree of probability that Jupiter is inhabited. Despite his belief in inhabitants on other worlds, Kepler was also entangled by Galileo's observations, which provided the heliocentric universe with some strong arguments. Up until this point in history, there really was no strong word against the geocentric view. It was easy to believe that everything revolves around us, and therefore easy for the Church to suppress anyone saying differently. The heliocentric system by Copernicus was known by the Church for 70 years, but was simply considered a hypothesis without truth. But Galileo showed the world that there are moons that encircle a completely different planet. How is this possible in a world where everything should revolve around us? Kepler addressed precisely this issue. Someone may say, if there are globes in the heavens similar to our Earth, do we argue with them over who occupies a better portion of the universe? What if the globes are nobler and we are not the noblest of all? The view on our globe changed. Scottish poetry William Drummond captured the wind of change in his novel Cypress Grove. The Earth is found to move and is no more the center of the universe. Some affirm there is another world of men and sensitive creatures, with cities and palaces in the moon. So science has become opinions and lead the mind in 1,000 labyrinths. The debate slowly creeps into the public mind as pioneer scientists risk their lives to publish the truth. Both Kepler and Galileo were closely watched by the Church. Galileo's prosecution was specifically interesting for the public. After his second book defending the heliocentric universe, he entered a skirmish with the Church that wouldn't come out good for him. Directed by his stubborn personality, he interfered in religious questions. In a letter to a cardinal, we can see his anger against religion. The Bible shows the way to go to heaven, not the way the heavens go. And this way of thinking was his tragic. He always made sure to draw a thick line between religion and science. Unfortunately for him, something that wasn't that well received back then. In 1633, the Church sentenced Galileo to a house arrest that would last until his death in 1642. With Galileo's telescope pulling the night sky closer than it ever was, the cosmic soil was ready for a new seed of thinkers. From that point on, the idea of life beyond Earth began to take hold, not just in the minds of astronomers, but also in the public. One man more than any other would play a major role in doing just that. In 1686, Bernard Le Bovier de Fontenelle wrote a book on astronomy for ordinary people, written not in Latin but in plain French, so everyone could daydream along. In Conversations on the Plurality of Worlds, he made alien life accessible. His book read less like a textbook and more like a fireside chat between friends. Fontenelle didn't argue, he wondered. And in doing so, he transformed the debate about extraterrestrials from radical to charming. I have taken it into my head that every star may be a world. I would not positively assert the truth of my opinion, but I believe it because it gives me pleasure. The influence of Kepler is evident when we take a look at his opinions on the moon. Some of its great cavities might provide shelter for the inhabitants from the excessive heat of the long lunar day. Fontenelle added to Kepler's speculations and introduced detailed ideas about the inhabitants of these worlds. Each type of planetary inhabitant was the prisoner of his respective atmosphere. Just as fish are prisoners to the water, people are prisoners to their world. It might be interesting to point out that roughly at the same point in time, the discovery of new worlds overseas led to a heated debate on the unique status of the human being. So the field of view already shifted to cultures away from the country. Why not also dream about cultures away from the planet? If you could describe frogs by looking at the swarms, why not describe aliens by looking at their planet? So that's what Fontenelle did. The inhabitants of Saturn? Quite phlegmatic, people who don't know how to laugh and who always take a day to answer the slightest questions. Venus? Little black people, scorched by the sun, witty, full of fire, and very amorous. Venus was specifically interesting because it not only is roughly the same size as our home planet, it also has an atmosphere. A thick, cloudy atmosphere that prevents the surface from being seen. But what could not be seen was free to be dreamed, and so Venus became the place no one had deemed. In 1726, Francesco Bianchini built a 25-meter-long telescope to observe Venus. With his sketches of evolving dark spots, he claimed not only to measure the rotation of the planet, but also that he saw what might be beneath the clouds. What he observed was perceived as nothing short of spectacular at the time. Bianchini was certain he saw an opening in the atmosphere and basically got to look on the surface. He compared his findings to the dark spots of the moon, which at the time were still highly discussed as being liquids. The discovery of a celestial twin was in the air. It seemed like only a matter of time until signs of Venusian cities appeared inside the lens of the telescope. Today we know that Bianchini did not see the surface of Venus. While we can't be sure what exactly he observed, we know that at the time dark spots were associated with a lot of Earth-like features. Back then, every yet so small observation in the sky was immediately filtered through the knowledge about our planet. And once something looked even slightly familiar, the idea of alien life wasn't far behind. Dark spots, clearly valleys or lakes, an atmosphere must mean breathable air, clouds meant weather, weather meant rain, rain meant water. You get the idea. Anything that even remotely resembled Earth's conditions was treated like an Earth-like condition, and Earth-like conditions meant life. We today know that planets can be wild. Worlds of volcanoes, sulfuric acid or ice became kinda accessible with powerful telescopes, but back then, everything we knew was Earth. We could not know that our planet is just a lucky variation of what is out there. This Earth filtration becomes apparent in many places, but perhaps the most when looking at the ashen light of Venus. The ashen light is described by a faint light emitted by the night side of Venus, rendering it visible to observations. This could be easily explained by a phenomena called earthshine. It's when sunlight reflected by Earth illuminates the night side of the moon. So it is reasonable to assume that the night side of Venus is illuminated by a Venusian moon. Except Venus doesn't have a moon. Franz von Paula Grüthusen declared that the ashen light had been seen in 1759 and again in 1806, an interval of 76 Venusian years, perhaps the lifetime of a Venusian emperor. The observed appearance is evidently the result of a festival illumination in honor of a new emperor to the throne of the planet. Grüthusen later modified his explanation, and instead of a Venusian coronation, he suggested that the light might be caused by the burning of large areas of jungle to create new farmland. The ashen light remains one of astronomy's enduring mysteries to this day. Some call it an optical illusion, others a rare and fleeting celestial event. But what is clear is that despite modern technology, the ashen light has never been captured on camera. It's tempting to dismiss what we can't confirm, but nowhere is this more careless and negligent than in astronomy. Absence of evidence is not evidence of absence. For centuries, the Moon, Venus, and Mars stood out as the most promising candidates for life beyond Earth. Not only because they were close, but also because they offered just enough familiarity to spark imagination. While the other planets did draw some attention to alien ideas, there were early reasons that led most astronomers to set them aside. Mercury was a world of extremes, airless, scorched, and simply too close to the Sun to hold much promise. Jupiter and Saturn were perceived as magnificent, but weird. Fast-moving bands, swirling storms, and shifting shapes were exciting to observe, but it was clear that no living being could wander these worlds when there's no ground to stand on. And so, attention returned to the familiar candidates, Mars, Venus, and the Moon. But not for everyone. One of the most celebrated astronomers, William Herschel, chose to look somewhere far more extreme, not to a nearby planet or moons, but to the Sun. For most of human history, the Sun was beyond question. Perfect, pure, divine. A flawless sphere of fire, untouchable and unchanging. This changed in the early 1600s. When the telescope entered the scene, so did the imperfections. In 1611, Johann Fabricius, a young German astronomer, was the first to publish observations of dark spots on the Sun. He saw them move, he saw them shift, he saw the Sun rotate. A year later, Galileo Galilei and Christoph Scheiner began publishing their own studies. Both claimed discovery, neither agreed on what the spots were. Scheiner believed they were planets or satellites orbiting close to the Sun. They are not on the Sun, but pass between us and it. Galileo disagreed and argued they were on the surface or just above it. These spots are carried around with the body of the Sun itself. It is therefore inevitable that they adhere to the Sun and are not some wandering bodies. For decades the mystery remained. Were they clouds, floating continents, burning mists, or simply shadows in the light? William Herschel found the solution. At least that's what he thought. Herschel had already discovered Uranus, he had mapped the Milky Way, revealed infrared light, and made his name as a giant of astronomy. But when he turned his telescope to the Sun and started to dream, his streak would end. Herschel believed the Sun was not a ball of fire, but a planet disguised in fire. Earth-like, structured and alive, just with fire around it. Herschel understood the Sun's spots as either holes in the fiery shell, openings in the luminous clouds which surround the Sun and through which we perceive the dark body of the Sun itself, or mountains standing 300 miles high. There can be no doubt but that a mountain much higher would stand very firmly. Underneath the exposed fiery shell lies an atmosphere followed by an Earth-like world, which he stated were teemed with people, protected from the heat, living in constant twilight. The Sun is most probably inhabited. Its inhabitants, being shielded by its atmosphere, may enjoy a comfortable situation. It was bold, but Herschel wasn't just any stargazer. He was the astronomer of his age, and when he spoke, people listened. So when Herschel said the Sun might be inhabited, he wasn't laughed at, and he wasn't alone. At the time, the idea of life beyond Earth was fairly common. Not strange, not fringe, it was part of how people saw the universe. The real question wasn't if life existed, it was where. Herschel didn't start at the sun. Before imagining Solarians, he turned his telescope toward the moon. And it shows how his desire to talk about alien life was deep-seated. In a series of discoveries, he first believed he'd found 3 volcanoes, one of them actively spitting fire. I perceive 3 volcanoes in different places on the dark side of the moon. 2 of them appear to be either nearly extinct or in the process of erupting. The 3rd is actively erupting fire or luminous matter. And then announce his observations of lunar cities and structures. I am convinced that those numberless small circles we see on the moon are the works of Lunarians and may be called their towns. As for why all the cities appeared perfectly circular, Herschel offered an ingenious explanation. The Lunar Architects, he proposed, had solved the problem of sunlight by designing every city like a concave mirror. The outer buildings would reflect light inward, ensuring that even the deepest courtyards and shadowed streets were bathed in sunlight, no matter their orientation. It was a clever adaptation to a unique challenge. The moon, after all, has no atmosphere to scatter light across its surface. Without such engineering, entire settlements might lie in darkness. In 1835, the New York Sun reported something astonishing. John Herschel, the son of William Herschel, had discovered life on the moon. Not hints, not traces, but a thriving lunar civilization, complete with temples, forests, and intelligent beings with wings. According to the paper, Herschel's team had constructed a massive new telescope in South Africa, powerful enough to peer deep into the moon's surface. What they saw was nothing short of extraordinary. Vast plains dotted with sapphire lakes, herds of strange animals, towering vegetation, and most famously, the Vespertilio Homo, bat-like man gracefully gliding on the moon's surface. The story was published in a 6-part series, each more elaborate than the last, each accompanied by illustrations. The reports were presented with scientific detail, rich language, and an air of authority, and the public believed it. Because John Herschel was real, because telescopes were real, and because science was advancing faster than ever, and if there were cities on the moon, this is exactly how we'd find them. John Herschel had never made such claims. The telescope didn't exist, and the entire story was a fabrication, written by journalist Richard Adams Locke. It was meant to poke fun at pseudoscience and public gullibility, but instead it became a sensation. For a brief moment, lunar life felt real, because the people at the time were more than ready to believe it. Herschel had planted the seed of possibility, Locke, knowingly or not, harvested it. When the fever passed, it left behind a silent truth. Just a few years later, German astronomers Wilhelm Beer and Johann Heinrich Mädler turned their telescopes toward the moon, not to speculate, but to observe. They created the first accurate and detailed lunar maps, crater by crater, ridge by ridge. The results? No temples, no Batman, no illusions. What they saw was desolate, silent, and real, but in its own way just as profound. The Batman vanished, the moon was desert. Although the wild assumptions of Batman were pretty much silenced with these maps, centuries of speculation never fully disappeared. Well into the space age, life was still on the checklist. Before Apollo 11, Carl Sagan highlighted serious concerns that astronauts might return with deadly organisms. His warning likely influenced NASA's decision to establish a lunar receiving lab, where astronauts were quarantined for 3 weeks after their return, just to be sure they didn't bring back any unwanted passengers. The moon was too dead, Venus too secretive, so eyes turned for the final time where they remain to this day. Mars. Mars was distant but not too distant. It had seasons, polar caps, and a surface that seemed to shift with time. If any planet might carry the torch of life, Mars might be our last resort. Dark spots like those of Venus were a common observation. They were observed on Mercury, on the Moon, and on Mars. The spots on Mars became specifically interesting when Italian astronomer Schiaparelli created detailed maps of these spots, which appeared as remarkably linear. In his book, he labeled them as canali, which is Italian and translates to channels, but was mistranslated to canals in the English translations, a word that implies that they were artificially created. Astronomer Percival Lowell picked up the translations and became utterly consumed by the idea of artificial canals. In a series of 3 books, he mapped the canals of Mars in great detail. Hundreds of lines, straight as geometry, stretching across the Martian globe. From poles to equator, continent to continent. Where the lines crossed, dark spots appeared. To some observers they were just patches of shadow, but to Lowell they were clusters of life, junctions in a grand planetary system. What he saw wasn't random, it was ordered, intentional. A world that had adapted, a planetary machine, a civilization holding on. But not everyone saw what he saw. Even in his lifetime, Lowell's peers grew skeptical. First and foremost, the man who started it all, Giovanni Schiaparelli, urged caution. I do not wish to imply that these canali are the work of intelligent beings, but they are curious and deserve further attention. He had never meant to suggest they were artificial, but once the word canals took hold, it was hard to walk it back. Martians built 2 immense canals in 2 years. Vast engineering works accomplished in an incredibly short time by our planetary neighbors. Mars inhabited, says Professor Lowell, declares the planet to be the abode of intelligent and constructive life. There is life on the planet Mars. Professor Percival Lowell, recognized as the greatest authority on the subject, declares there can be no doubt that living beings inhabit our neighbor world. As the canals gained popularity, his skeptics became more direct, actively trying to disprove him. I have never been able to see anything in the nature of canals on Mars. No evidence of straight lines or anything resembling canals. We today know that there is no civilization or canals on Mars, but a question remains. What did Lowell see for 15 years, if not canals? Astronomers of the late 19th century worked at the edge of visibility. There were no photographs, no sensors, and most importantly, no second chances. Only the human eye pressed against the telescope and the mind looking for meaning. In 1903, Edward Maunder and Joseph Evans conducted a psychological experiment. They showed volunteers random dots and asked them to sketch what they saw. And what appeared in their drawings was quite surprising. Lines, patterns, geometry. The eye had connected what wasn't there. These results and Lowell's canals are believed to be the product of pareidolia. Pareidolia is a now well-known psychological phenomenon where the mind perceives a familiar pattern, like shapes, faces, or structures, where none of them actually exist. It's why we see animals in clouds or a man on the moon. Lowell wasn't dishonest, he was convinced by lies constructed by himself. What he saw was not born en masse, but in the space between perception and belief. But while Mars would remain without canals, his visions still sparked the imagination of a whole era. And that's why the myth of Martian canals was here to stay. Long after science had already moved on, science fiction kept playing with the idea. But in 1965, the final word arrived. Mariner 4, the first spacecraft to fly by Mars, sent back photographs of the surface, and canal believers were in shock. No canals, no cities, only craters and dust under a sky far thinner than we had hoped. The illusion was over. But the Martian canals weren't a failure of science. If anything, they were a reflection of human curiosity, the desperation to end our cosmic solitude, and perhaps more than anything, a lesson. Sometimes the night sky shows us more about ourselves than the worlds we try to reach.